Hello everyone, welcome to First Class Solutions. Today we're providing solutions to this matrix problem we have on the board. This is a simultaneous equation problem also, and it can be solved using the Cramer's rule. Before we understand the concept of the Cramer's rule, the idea of determinants is very important because determinants, matrix determinants will be obtained from these equations and they will be used to set the problem from which we will get the solution. So to get that matrix from this problem, we just simply need to take the coefficient of these our unknown, the coefficient of x, coefficient of y, then we'll take the coefficient of this x here and coefficient of y. Use it to form a 2 by 2 matrix. To form that matrix, the coefficient of x here is 2, coefficient of y here is 6, coefficient of x here minus 1, and coefficient of y here is 5. So what do we have? We have 2, 6, minus 1, and 5. And what we are looking for, the unknown are x and y, our unknown, being equal to the constants we have here, being the solution values as 22 and 53. Now with this, we've gotten to a point where the idea of determinants is becoming very important. So to get the determinant of this matrix, let's call this matrix matrix A. To get the determinant of this matrix, we need to simply multiply 2 by 5 and 6 by minus 1, then subtract the product and get the value. The value becomes our determinant. What are we saying? Determinant of A determinant becomes 2 times 5 being 10 minus 6 times minus 1 will give us minus 6. So we have minus 6 here, where we have minus minus becomes plus. So we have 10 plus 6, and the final answer for these determinants will give us what? 16. So if we have 16 as this determinant, it is not the end of the road for us. It continues because according to the Cramer's rule, to get the value of x, we need to get a special kind of matrix that is obtained by replacing each of these column by these solution values. What are we saying? To get x, you need a special kind of matrix that will be obtained when we replace 2 and minus 1 with 22 and 53. Whereas to get y, we need another kind of matrix that will be obtained when we replace 6 and 5 with 22 and 53. That means to say, when you now get the determinant of those special kind of matrix, you just simply put their ratio and you get your answer. Meaning that those special kind of matrix, let's say we're looking for x, let's say we're looking for x, we have a special matrix called x, whose determinant will be over the original determinant we have to get the value of x. Whereas if we want to get our y will now be obtained from a special kind of determinant, whether from a special kind of matrix, let's say matrix y, whose determinant will be over this our original determinant a to now get the value of y. So let us put what we are saying into practice so that it will be easily observed by all. Now, to get that special matrix, just like I explained earlier, we just simply replace this and we'll say, let's call that matrix matrix x being equals to, we replace 2 and minus 1 with 22 and 53. We have 22, 53, and what? 6 and 5. Now, this determinant, x determinant, the determinant of this matrix will now become 22 times 5 will give us 22 times 5 will give us 110 minus 53 times 6 will give us 3 318. Yes, 318. 22 by 5 110 minus 53 by 6 318. Now 110 minus 318 will give us minus 208. Now it will give us minus 208. And having this minus 208, this is the determinant of this x matrix. This is our new matrix, our special kind of matrix. So to get the value of our x, according to the Cramer's rule, x now becomes equals to minus 208 over 16. So we have equals to 208 over 16. Let's punch our calculator. 208 by 16, 208 by 16. We have 13. So our x is 13. We've obtained our x to be 13. We are looking for x and y. So we'll proceed to get our y. So our y in this case, to get that y, you need to follow the same step you use in getting x. So you obtain a special kind of matrix also for x, which is gotten by replacing 6 and 5 with this your column matrix here. So we have, let's call that matrix y being equal to 2 minus 1 and what? 22, 53. Yeah. Now the determinant of this matrix is, let's say y determinant is 2 times 53 will give us about 106. Yes. Then minus 22 times minus 1 will give you minus 22. So 106 minus 22 is the same as 106. Minus times minus will give you plus. Then we have plus 22. All equals to 106 plus 22 will give us 128. 128. So the determinant of this new matrix is 128. But we are looking for y, not just the determinant of the y matrix. So to get y, according to the Cramer's rule, we just need to do 128 over 16. So our y, therefore, our y is equals to 128 all over 16. And our y is equals to 128 over 16 is equals to 8. Our y is equals to 8. So these are the ways of solving this kind of problem using the Cramer's rule. Thank you very much for watching. Thank you so much for watching to this period, and also do well to share this video to your friends so that to enable them meet up with what is expected. God bless you. Bye bye.